Hello, my name is Chip Paul, and I'm founder and president of GnuPharma. And I'm here today to give you a brief explanation of our science. The first thing that you need to know about sort of what we've done is we need to sort of go back in history a little bit. And in science, it's very important to find something called a common ancestor. So if we were discussing the point at which we diverged from fish, we would go back and find that common ancestor that was a fish that first developed legs and walked out of the ocean. Well, similarly, we want to find, two things really. How far back or in the evolutionary time do we have to go to find the first critter that had something called an endocannabinoid system, or ECS? And then what else, would that have in common? So meet the Hydra. The Hydra is how far back you have to go zoologically to find the first organism that had an endocannabinoid system. And a Hydra is a very simple organism. But the Hydra is also a common ancestor, and he's a common ancestor for something that we all have called a central nervous system. So the critical point here is at the same time we were developing something that's quite necessary for us to live, a central nervous system, we were also developing an endocannabinoid system. And it's kind of a chicken and the egg argument, what came first, but there are indications that certainly you would need an ECS before you needed a CNS. And we'll kind of discuss that on the next slide. So the other interesting thing about your endocannabinoid system as a neurological system is it works different. So in normal circumstances, your neurotransmitters are stored in things called vesicles in your neurons, which are represented here by the orange circles with the black dots. In an endocannabinoid neurological event, you can see the little endocannabinoid guys are represented by little green squares here. But in an endocannabinoid event, those neurotransmitters are not stored, they're manufactured on demand and at the time of need by that neuron. Now that's a very different and interesting way to fire that neuron. And I would argue, again, simpler and more basic. But the critical point here is that your neurons have to have the resources basically to be able to manufacture endocannabinoid neurotransmitters on demand. And if you don't have these resources, you don't work. Your neurons won't fire. So just to recap those two critical points, we developed something called an endocannabinoid system, or ECS, at the same time, or we have a common ancestor for the development of the CNS, or central nervous system. So those are at least equal systems, if not one superior to the other. Critical point two is that this really the simplest function of our neurons in an ECS event, that is a resource event that has to be generated on demand. And if your neurons don't have the resources to generate that event, it won't happen. All right, so again, we're in our model, we stand on the shoulders basically of science. And so this is some of the foundational science that we're standing on the shoulders of. Certainly we're standing on the shoulders of a guy named Raphael Mechoulam. Raphael was the first guy to synthesize THC back in the 1960s, but he really is the father of this system. It was first discovered really in the 90s when he discovered anandamide. Was pretty heavily researched really all the way through the 90s. Certainly pharma did a lot of research here. In the early 2000s, another internal ligand for this system, the endocannabinoid system, was found called 2-AG. And it turns out that 2-AG solved kind of a big problem in neurology, and that's how it basically is responsible for retrograde signaling, and no one really understood how retrograde signaling worked before they discovered 2-AG. So, critical point there is without 2-AG, you can't retrograde signal, and you don't go. So the ECS really, and again, in 2000 this happened. There's been quite a bit of research, and the next slide we can talk a little bit about the research. But really, the endocannabinoid system is just beginning to be taught in major universities, and it's now taught in probably 20 or so major universities. And even though there's tens of thousands of research papers out there, I would argue that really research has just begun on this system. So people are just really beginning to put together the pieces as we have done here and speculate on what this system could do. And as we say there in the green, the research curve is just beginning on the ECS. So what does this system do and what does it affect? And again, this is based on research, hard research here. And if you go out to nih.gov and you go to the search bar there and you type in endocannabinoid system, and really any human system, there'll be hundreds if not thousands of research papers there. But you can quickly see here as we read down this thing that kind of our capital systems or our main systems as humans. The endocannabinoid system plays a very large regulatory and management role in, and that would include the immune response, our feeding and craving behavior. I don't have reproductive up here, but it heavily plays in reproductive, pain, mood, memory. All of your major systems as a human are, the endocannabinoid system plays a major regulatory role or sensory role in. And please feel free to satisfy yourself with the research that's out there. So what have we done that's unique here? Well, we've stood on these shoulders and we've really built a model that says that your endocannabinoid system is really your everything. It completely runs you, and it runs you through your brain. And again, the next slide, I'll go in there deeper. But we now have our ideas here heavily supported by evidentiary research, and our own directional data and our anecdotal data. So we feel pretty confident we're on the right path. All right, what is our sort of model and approach? Well, I'll kind of walk through this slide, but I'll talk about it in kind of my own words. And really, if you think about something like an automobile, right? And your automobile, in order for it to function properly, it's a complicated piece of machinery. It has a computer, and that computer is constantly monitoring that automobile, things in that automobile like their carburetor or fuel level or oil level or just a myriad of different things are being monitored in that vehicle. And adjustments are being made based on the feedback there. So let's take something like if you're almost out of gas, well, a light's going to flash and it's going to warn you and say, go get gas. Or if your oil pressure is low, you're going to get similarly warned. There are some adjustments, certainly, and things that happen within your engine and all of that happen automatically that we're not even aware of, but that are managed by that computer brain system. Well, very similarly, we think the intelligence for the endocannabinoid system rests with the hypothalamus, and for more basic functions, really with the hippocampus. But there's tons of data indicating that, when an ECS event happens, your hypothalamus lights up at the same time, and lots of data here to indicate that would be the case. And basically, through the endocannabinoid system, the hypothalamus or hippocampus, that intelligence manages and controls our functions. But it can only do so to the extent that it has resources. And that's a very important statement. Just like a vehicle without hydraulic fluid cannot, manage those hydraulic functions. So the ECS really plays a role in every human physiological function. And please feel free to satisfy yourself there with the research. You can't function without an ECS. It's absolutely critical to your neurology. It is the master body regulator. It's the master regulator of your CNS. And again, that's our model, but there are lots of data that would support that. Organs are certainly regulated or balanced through ECS actions. And again, there's hard research there. Neurology is regulated through ECS actions. We have directional data, anecdotal data, and lots of research data there. And this is a variable system. So over the course of a day, even your resources here will change. And certainly this system can be influenced. And that is something that we've done that's very novel and unique. We've built this system of influence, and we've demonstrated that numerous times. Certainly cannabis can influence this system, but we've proved numerous times that our herbal system can influence. And we believe that our model is predictive. And what that means, let me give you a quick example of what that means, is if we're looking at something like weight loss, right? So weight loss for a normal person and through endocannabinoid eyes is pretty easy to achieve. So if you lower the endocannabinoid tone, or basically lower the amount of endocannabinoids in the hypothalamus, that's what sort of cues your body to shut down your feeding or craving behavior. In obesity, it's completely different. So there's a completely different set of circumstances, and we've used those circumstances and knowledge of those circumstances to basically engineer or build a formulation that we think will better address obesity. So by virtue of knowing some very basic information, we can engineer formulations at very specific conditions. So that's really the power of our system. All right, so contact information, certainly if you need to get a hold of me, I'm just Chip at GnuPharma. There's our phone number there, website. Certainly feel free to contact us at any time if you have any questions or need any information. And again, I appreciate your time today, and thank you very much for listening to our presentation.